friends, today I'm going to show you how to create a 240 volt DC line. So in order to do that, we are going to use a diode bridge and a capacitor. We directly convert 240 volt AC to 240 volt DC. Not when we are converting, it will be more than 240 volts. So let's go ahead and start up. So let's go ahead and open Proteus. So I'm going to edit the last circuit that we drawn from last video. So most of the items in the last circuit are required the same. So I'm just going to go ahead and edit that circuit. Alright, so we need this diode bridge and this lamp, of course, and other than that everything's gonna be removed. Alright, so let me go ahead and remove these. Alright, now of course this one don't come here. So now this is the diode bridge. So in order to create the DC current, we need a diode bridge. So this is a full bridge rectifier. So if you want to learn more about full bridge rectifier, I suggest you go to Mehdi's Electro Boom channel. So he explained full bridge rectifier in detail. So I put the link there into that video here. So now we need full bridge rectifier like this and the smoothing capacitor. Alright, so for smoothing capacitors I'm going to use electrolytic capacitor here. So here the capacitor. So let's get the generic electrolytic capacitor. Alright, now the capacitors connections like this. So the capacitor we are going to use 270 mu F. The voltage is 400 volts. That is because we are dealing with 230 volts here. Alright, so the negative side goes to this line. That is because these are minus in the diodes. Alright, so this is the minus line and this is of course the positive line. Alright, now so let me clean this a bit. Alright, so we can go ahead with this and we can connect this line. So we have the AC line. Now the circuit is complete, but there are a few more things that we should taken care of. Alright, first off, this capacitor is connected directly to the diode bridge, so it may cause damage to this diode bridge. Here's how. At the first, this capacitor does not have any more current. Alright, the charge of this capacitor is 0. When we turn the current on, so when we turn this AC line, this one start charging. Alright, when it starts charging, it draws huge amount of current at first and then it reduces its current. That may lead us to damaging this bridge. So in summary, when you start the circuit at first, when there is no charge here, this one acts like this, that is direct short circuit. Alright, so for small amount of the means for microseconds or nanoseconds amount of time, this act as the short circuit. Alright, so the diodes can hold higher surge current in a nanosecond or microsecond range, but sometimes this may damage this diode bridge. So this does happen to me when I was creating this 230 volt DC AC to DC converter in a couple of years back. So when I connected that this way, this diode bridge damaged. Alright, so most of the diode gets shorted up. So the better way to do is use an NTC. So NTC is a thermistor, so it has a resistance. Let's say in this case we can use a 10 ohms resistance NTC, So initially NTC has the 10 ohms resistance, and when the current goes through the NTC, it gets heated up. So when the NTC gets heated up, the resistance of the NTC is reduced. So let's grab an NTC. So NTC like this. So I'm going to use a for this one I'm just going to pick up this 100 one. Alright, so basically we need 10, so you can use NTC calculators in internet to figure out the value you need. So in my case this will be 10. Alright, so what happens, this is now initially, as we know, this is going to be a short circuit. Alright, but this one limits the current. Alright, so since this limits the current, this diode bridge get protected. Alright, now when this is charging through this NTC, and this one absorbs current from this diode bridge and the NTC gets heated up. Alright, so when it's heated up, the resistance of the NTC is reduced. Alright, but at the time the resistance of the NTC is reduced, let's say for 2 or 3 ohms, this one already charged to some state where it no longer requires the huge amount of current that it required at the beginning. Therefore this diode bridge get protected. Alright, so assume that this one has 0 ohms somehow or 1 ohms. At the time that it reaches 1 ohms, this one has enough charge so it don't draw more current from this diode bridge, so this diode bridge get protected. Alright, so our output of course like this. So our output lines connected to this line. So if we check in the Proteus multimeter, we may not able to start the simulation. Alright, so let's anyway go ahead and check with the voltmeter here. So we are going to use DC voltmeter, so let's go ahead and check. So if we start, so we have 229 volts, but in reality if we apply 230 here, there will be much higher voltage here, so somewhere around 270 to 80. Alright, so let's measure that one too in our real circuit. So, and also I'm going to use another inductor wire here in order to reduce the ripple here, so in the output line. I will also include that in the actual circuit. Also for additional safety, I'm going to use another fuse in this line in the real circuit. So let's go ahead and check the real circuit and test it out. Alright friends, this is the circuit that we designed from the Proteus. So one notable difference is you cannot see any diodes in this circuit, so that is because this is the diode bridge that I have used. So this is a direct diode bridge, so you can purchase this direct diode bridge from the electronic shops. So it has 4 pins, I believe you can see this. So 2 of them are here and 2 of them are right here. So these 2 pins receive the AC signal and outputs DC to these 2 pins. Alright, so this is of course the fuse, and this is the AC in. It goes through the fuse and to the diode bridge, and the output DC goes to this capacitor. But as we discussed, it goes through this NTC. Alright, so this direct DC goes through NTC to this capacitor. Alright, and the output of this capacitor goes to these output lines. So this diode bridge is not a high ampere one, this is just 2 amps. Alright, so you cannot use this diode bridge for heavy duty applications. Alright, so this is the ripple filtering coil. This is just a wire that turns some few rounds, so it goes from ground to this one, this output ground. All right, and this plus side is directly connected to the plus side of the capacitor. So this is the circuit, actual circuit from the design. So let's go ahead and check this out. Alright friends, so here we are. Now we are going to test this. So I'm going to plug this in like this. As you can see, the light turns on. Now this is 230 volt DC, not AC current. Alright, so I will show you the measurement in a moment. So now this bulb works on 230 volt DC. Alright, so if I remove the plug, notice, you see, it'll take some time to completely turn off. That is because this capacitor holds the current. Alright, so this is the end of this video, that is creating a 230 volt DC circuit. In next video, let's assemble the FET and 12 volt power supply and PC817 optoisolator to control this bulb directly using 230 volt PWM. So as you can see, we have 286.7 volts in the DC output compared with the Proteus value, which is 229 volt DC. So as I said, the output DC is always greater than the input AC voltage. So until then, don't forget to subscribe to my channel, that is Fun Text with Hashan, and do not forget to click the bell icon so you will be notified when I upload any video. So with that being said, thank you very much and thanks for watching.